the business. All right. Just in case, just in case. Okay. Again, my name is Randall. It'll be my pleasure today to help you learn about R, the basics. Some of you have never coded before in your life. Others of you are more experienced with code. There'll be some sections where obviously you are more familiar with the content than others. But again, this workshop is meant for people who want to learn more about visuals. But in order to do that, I do need you to have a brief, tiny introduction of what R can do and computing programming vocabulary and things like that. So, one of the things that, hold on one sec. One sec. One sec, I have to change something up for a split second. I just realized. Give me a moment. One sec, guys. Sorry. I have to make sure some aspects for the online people. Sorry. This is actually my first time doing a in live and remote dealio, so you're gonna help me learn something new in my world. And people who are remote, at the very end of today, there is going to be a survey. People on the online piece, please do your best to give me some constructive criticisms. We definitely want to make this available again through a remote piece, and so. I want to make sure that we're able to do that in the future. So hold on. All right, let's begin. Let's begin. You're entering a world of visual. And data can come in all sorts of shapes and sizes. Maybe you need a network plot of your favorite book. Maybe you want to talk about the best song to listen to from the last 100 years. So you use a mosaic plot to do that. Maybe you want to get political and have a visual way of showing gay rights. Something more aesthetic that lets people understand that what we have and what we don't have. Or maybe you're just trying to take the world and give it some meaning. Whatever it is you're trying to do with your data, it starts with understanding the basics. How do you visualize data, and how do you work with data from just, a lot of you are doing your own research. No one's doing your research for you. How do you start from that step? And that's what today's workshop's about. I want you to get familiar with RStudio. I want to teach you basic coding, basic aspects of vocabulary that's useful when you do code. I want you to be able to create your own data sets. And I want you to be able to visualize those data sets. So that's what you've come here for, and that's the journey I'm going to take with you. So let's start with the very basics. Shortcuts. Everybody loves shortcuts. You need shortcuts. Okay? Shortcut you're going to use a lot. Control-Enter. That's going to run your code. You have a line of code you want used. Control-Enter is going to run that line of code in RStudio. Another important shortcut is Control-Shift-H. Control-Shift-8 is going to set your working directory. That working directory is how you're going to pull data. That working directory is how you're going to know somebody created a data set for you. How do you pull that into R? You need that working directory for your work. Alt plus the minus key is what's called an assignment operator. An assignment operator in coding language looks like this. It's equivalent to equals. Some people code with assignment operators, some don't. I'm going to teach you to code with assignment operators because that's how I was formally trained to do it. Again, I'm not trying to change what you've already established in your own coding ethic, just want you familiar with what I'm doing and the shortcuts in order to get to where I'm going. Now sometimes, and coders will know this, sometimes we break our programs. They go on forever. We can't stop it. The escape key is our friend at that moment. We did something, we coded it, the machine said, we're going to do exactly what you did. It's stupid, but we're going to make it happen. Well, then you're going to have to hit the escape key because your program's never going to stop running. It's going on for you. You put it in an infinite loop of sadness. And last but not least, Control-O. I'm going to need you to hit Control-O right now, and I'm going to need you to open that file that I had you access through the email, which had all the files of the data frames, and had all the shortcut templates, and also the R file, introduction to R.R. So the particular file I'm talking about is this one, right here, introduction to R. That's the one I need you to open right now. Now, we have people in the back, too, ladies and gentlemen, who are willing to help you and assist you through any technical difficulties through today's workshop. Please, something's not going right, raise your hand. You're not able to access the things I'm telling you to access, raise your hand. Okay, people in the back, will you go ahead and assist these ladies right here? Yeah, keep your hands up. We want to make sure that you can come. And I'm going to walk around. Everybody else? Save all these files. If you have not saved the files from the Dropbox, you need to save them to your desktop. You're going to be using them in today's workshop, so you must have all those files.
Does that help? Like, helps a lot. Yes, it gets really but it just and then it's not. Yeah, I usually sit back.
Now, anybody did show up if there was room for a last minute entry. You didn't have access to the files I'm talking about because we had full capacity registration. You'll have to appreciate the workshop for as best it is because I can't get you those files at the moment, or you can maybe have your neighbor email them to you. If you do not have R Studio loaded right now, there'll be a moment where you can get caught up in the workshop. I'm going to push forward, but you will need those two softwares in order to do what we're doing. But once you open this file, this is what should pop up when you have all the appropriate software. This is the RStudio IDE. For the most part, I think I know what you're thinking. Does my RStudio IDE look as complicated as yours? There are a lot of things going on right here. I'm going to introduce the basics of each part of those so you don't have to feel overwhelmed. I will not teach you every aspect of this IDE in today's workshop. I'm going to teach you the important things that are necessary for you. You want to work with data, you want to do some data visuals, I'm going to show you the point where you can go. However, what I have done is I've created a cheat sheet for you. Well, actually, I didn't create it. I found it for you so that way you can actually go through this later on your own time and you can actually learn more about RStudio at that aspect. But IDE stands for Integrated Development Environment. The R and the RStudio work together. R is the GUI. The RStudio is the environment that lets you work with code. And so even though you didn't open the actual R software, RStudio is using that in the background. Now this cheat sheet right here, the RStudio cheat sheet, it's PDF. So if you open this PDF, it's 2 pages. As you can see, it's a hot mess. It's a hot mess of a lot of things. This very first page, though, is going to guide you in what we're working in our platform. It's going to show you where you can write your code. It's going to show you the console, which is actually implementing the R GUI. It's your workspace where your data is going to be saved. And this area right here has many functions. Help you with files, the plots will go there, the help section's in there, the viewer section using certain packages will go down there. So this has multi-tasks to it. But again, if you want, you read this document on your own later. It'll teach you every aspect of the RStudio IDE. But tips for today. One of the tips in general is I like to change the color of my background. I don't like all white. All white makes me sleepy. It makes me hate coding, actually. I don't know why. I've never liked it. RStudio will allow you to do this. So after today's workshop, if you want to try and customize your RStudio, me and our workers, we'll get you what you want. You'll leave here with this RStudio IDE that you like. I tend to go with darker colors. I don't know if that means I'm a dark person, but it's what I like. Okay? How these slides are going to work for you. I've had you open this file, and I want you to be able to understand what I'm doing in today's presentation. For one, in today's presentation, when you see a slide titled Assigning Arrays, I'm talking about this section of code. So you'll always know where I'm talking about and what code is going with what I'm presenting currently. Okay? One of the things in today's presentation, though, these comments, so in the coding world, you can actually comment things that don't get run. It's your way of keeping track of your code, because if you open code 4 months from now, you don't remember what you did or why you did it. So comments are very useful. This is not in my PowerPoint presentation. So you'll never see these in today's presentation. The only thing you're going to see in the presentation is this chunk right down here below. And that's going to show you what I need you to look at. So now you understand how today's presentation is going to work in regards to how I'm going to reference it to today's code. You can open your own R script if you want up here. So if I ask you to do something and you want your own clean page, you can go and open that right now. Or if you want to just add it to my current slide, I've given you this file. It's yours. Use it however you want. But I will be having you code a little bit of things. I figure just go along with what I'm doing, add it in at your leisure, and again, you'll have people to ask questions for if you have troubles. So let's jump back to the actual presentation, now that you understand what I'm doing. Assigning arrays. For those of you who coded before, you know exactly what this means. For those of you who've never coded in your life, assigning arrays is how you save information. There are different ways to assign arrays. Strings, numeric arrays, things like this. I've started out with a very simple array. It's called hello, my name is Randall. You need this concatenation function in R. C parentheses, parentheses, in order to do these types of things. Right now, if you wanted to change Randall, put your name, you could. And again, this assignment operator is saying, save all of this to the word hi. And so if I actually typed in hi, again, you have to control enter this, type the word hi, hit control enter again. And just like that, it'll say, oh, you entered hi. You would save that array as hello, my name is Randall. That's an array. Simple. You can do it with numbers. Numeric arrays have awesome features. You use this concatenation, the C. Here are my favorite numbers, 1357. But if I wanted to multiply my favorite numbers by 2, I could tell R, take the number 2, the asterisk is the multiplication symbol. And then how did you save your favorite numbers? Oh, I saved them as favorite numbers. And next thing you know, it'll spit out, oh, your favorite numbers times 2 is 2, 6, and 14. So the benefit of numeric arrays is that you can actually use mathematics with them. Many numbers all at once. Sometimes you need to just spit stuff out you don't want it saved. R does that too. Okay, we're not going to be focusing that on too much, but in general, for those people who do code and they don't save everything, they're trying to optimize, it's called the CAT function. Okay? You put parentheses, you tell the message you want to do. So if you needed just a blatant, like, do this, well then, now get out. Workshop's over. Nothing was saved. I've ended the business. So this is the generalization of what an array is. Installing packages. Installing packages is the next thing you have to be familiar with now. Just like other coding languages, certain packages have certain features and whatnot. The formal name for any command with parentheses is called a function. In R, we use the install.packages function in order to install whatever you're trying to implement. Today, I'm going to need you to use the Rio function. You type install.packages, you put parentheses, you quote what function or what package you want to do, and boom, you now have the Rio package. Plain and simple. As much as I would love for our studio to just make it so I could just go visit the world, the nice thing about our studio is when you load a package, you only have to load it once, or excuse me, when you install a package, you only have to install it once. So the Rio package you install today, you're never going to have to install it again. Unless, of course, you completely erase our studio from the, of course, we're erasing that. But in general, it's a one-time deal. But R doesn't know when to use a package. It doesn't know when, oh, you installed the Rio package. When do you want to use it? Well, you have to tell R how to do that. That's where the library function comes in. And the library function is just saying, I need you to use this package right now. But if you don't put library and you try doing Rio, death. Okay? You're not going to be able to use it. Sadness is happening. We're talking about Rio. Okay? We're trying to make sure that you don't run into these technical problems, because I've seen people who've never used R before get really frustrated with just the basic packages because they can't use them. They don't know when they're using them. It's not loading correctly or whatnot. So we're going to alleviate all that frustration. Okay? There are 4 packages you need today, and DVC has kindly coded this for you. Okay? In the slide that says packages needed for today's workshop, what they've done is they've made it so if you need to install many packages at once and load them, you can run their code. All you have to do is tell them which packages you need in this, well, I call it workshop.packages. This is the code they wrote for you. So if you don't understand coding language, you don't need to understand coding language, okay? Don't worry about it. What you do have to understand is that the load.packages that this code created needs to hold what to use. So you're going to need all 3 things. So again, for simplicity purposes, just click anywhere on that title. Click anywhere on that title, and then all I need you to do is hit Control-Enter 3 times. Okay? It's going to run all 3 of those in sequence. And you know you've done it correctly, as at the very bottom in your console, it's told you the psych package is true, The Rio package is true, the car package is true, and the G control is true. Again, raise your hands if you need assistance, because we want to make sure that you get all these, you need all these packages for today's workshop. I broke something.
Yeah. Yes.
No, this code was given to you. Yeah, did you have the, did you download all the files for the workshop? Okay. All the codes.
What is that? I just loaded those. Yeah, or I assigned it to what that. Can't I just do no?
Is this the newest version of RStudio?
So when you have this. Also, what is for
Yeah, see, something's wrong. It's not the code. Actually, I think it's take too long. Yeah, just uninstall RStudio and install. Yeah, because that's what the problem is right there. You can't even use check to
I don't know.
Randy,
Yes.
the audio is cutting out a little bit from Nicholas.
Okay. I think it's
We're away from the front.
okay. All right, let's come back together, please. If for whatever reason you do have one of these is false and most of these is true, then that happens. I've told you just install .packages, put the sync there, package, and then right afterwards we run the library. That's one of the things. But in general, one of the things I have noticed about RStudio, and this happens, is if for whatever reason, and I think it's happened to me twice over the last 3 years, I can't install packages at all. Like everything just seems to break. It takes 7 minutes, but you uninstall RStudio and reinstall RStudio, and then it's fixed. I can't explain why. It's frustrating, but I have had that experience where just nothing will install or update, or any regular feature I'm not even coding is not. So, question.
Can I ask a general question?
Sure.
I noticed when I go back into art, like, is there a way I can just keep certain libraries open?
Unfortunately, when you close R, it defaults. It goes back to its regular. There is in your workshop an extra piece of code that I'm not formally going to go through. I've given it to you guys. It actually is a way to default R if you want to default R, but you can just close the program, open the program at the same time. One of the things I want to show you though, Roxanne, is that actually brings up a good point. There are times actually you're going to get the other problem. You're going to have too many packages, or you're going to have too many libraries open, and now R is getting confused, not because it can't handle lots of libraries, it's because, well, the programmers, they use the phrase summary, and then another program used the function summary, and then another programmer used the function summary, and R's all like, which one of these uses the function summary? Which summary am I? Because they're all doing different things. That's when you want to detach a package. I've talked to somebody personally who said the best way to just keep your code clean is if you know you don't need a function afterwards, just put this code where it is. It's like, don't even worry about it. Just make sure you're never double dipping. I just don't run this function. I just had installed packages. I wanted you guys, don't do this right now. Okay, I want you to touch anything. Okay? Don't do these either. But FYI, they're for you to know. One, you can detach all the packages with the function we wrote for you. Again, I'm not going to show you, it's in there. If you need to clear your plots, this is the function you use. If you want to clean your work environment, this is the function you would use. And if you want to clear your console, that cat function is coming into place. Again, it's that kind of like do something that I need you to do. Okay, but again, we'll go through those later. What's important is that sometimes we confuse ourselves too. We write good code, but we need to do it for several homework assignments all at once, and we have our environment starting to get crazy. Where we have a whole bunch of things in here, like X, a double X, a triple X, you know, whatever you're naming. And now you're starting to confuse yourself because you can't keep things straight, which array was meant for what. The broom icon is your way of just cleaning RStudio. You're just like, I want all this clean. Click the broom icon. It's not going to detach your packages. So it's just going to clean that environment right there. Same thing happens over here in the console. If you're trying to reference things and it's just going and going and going because your console is using the Arguri and it's saving what you did over and over, you can go back and look at what you implemented. You can clean that up. And last but not least, there's actually a broomstick right there if you click on the plots. I wanted to show you because people have told me, I've had this conversation with people over the phone, there's no broom icon. I was like, yes, there's a broom icon. Well, they had one of these other tabs open, so there's no broom icon for them. But if the plots, then there's the broom icon back. Okay? So just so you know about those types of things. Where are we at? Sometimes you actually want to know more about a package. You'll hear people brag about, this package is so good. This function will actually open a vignette, which will open a web page, and that web page will start giving you documentation about that package. So I want you to be able to, because today I can't teach you the ins and outs of packages. There's no way. But I want you to know that if you want to learn more about the packages I'm using, that's your way of doing it. And then you click on that, and next thing you know, here's some documentation. This is all about the Click package, how to use its functions, how questions, examples, and then you can build on your learning. So we've given you that function for you to use in future references. Scientific notation. I've met people who hate scientific notation. I've met people who love scientific notation. You choose how you want your R to output. You want it in scientific notation, that's the default. No worries. You want to take that off, here's the code to do that. You want to put it back in, there's the code to do that. I just want to make sure that you guys are seeing the code and the algorithms the way you want to because you're using your research for whatever reasons, okay? But with that said, let's see. I think that's enough basics. Any general question? R is not scary. R is pretty straightforward. All right, let's get into the meat. Start working with data. You don't want to be that guy who shows up to the meeting and don't know your data, ever. Know your numbers. This guy right here, I like his attitude. Because he says the bad news is that we can't show who our customers are. We can tell that they're unhappy. Okay? It doesn't say a lot. That's bad visualization. You want a plot to have meaning, okay, in every regard. A stranger can look at your plot and your visuals and say, that makes sense. Okay, I could probably make a decision based on that. Or that's helpful in me understanding the big picture. That's our goal for today. So I'm going to teach you some ins and outs. But it starts with data. You can't teach you how to plot data if you don't know how to get data or use data. Okay? I decided, let's make some creative data frames. Okay? First of all, we'll start with the calendar. Yeah. Okay. Some of you are like, never heard of them. Never heard of them. Okay, they're old school, people. They're old school. And there are 4 members Lars, James, Kirk, and Rob. But notice how I'm using this array. I concatenated 4 names. I wanted all their ages. So I made a numeric array of each person's ages. When you make information, you start by making these arrays, however you want to, whether they're strings or whether they're numeric. But there is a way to put them in a data frame. It's a simple code. Data.frame. What you want in the data.frame is the name of the arrays. But what I'm going to show you is that you can actually title them different titles. Let's say you did Metallica.names, but actually when you put it in your data frame, you're like, that seems such a long name, I don't want to deal with it. Let's just call it names. You actually can do that at this point. Oh, Metallica age, it seems like such a long name. How about we just do age? And when you save this array and you call upon it, there's your data frame. There are the names of the Metallica artists, and there are their ages. You've made your data frame. Done. So this is how easy it is to create data. How about right now? You make your own data. I made data. I did this before the workshop. Those numbers have no meaning in life. Why don't you go ahead? Make some data. For workshop purposes, I highly encourage that you title your arrays x2, y2, don't worry about that, and my.data 2. That way you don't, you can run my code and you can run your code at the same time. So that's how easy it is. Pick numbers, random numbers. Now there is a key point to make right now. These are the same length. And if you were to put them in a data frame, they must be the same length. So if you make this have 2 numbers and this have 12 numbers, you're going to get some problems. Okay. Will it default to NA, Dwight?
Should give you an error.
Should give you an error, right? Yeah. I've done other programs where it actually defaults to NA. R will just give you a straight error. It'll say not okay. Once you're done creating your array, you can call your own data frame input x2, output y2. You can create your own titles again, input, output. That doesn't matter because we're putting that in the data frame. That's not changing the array itself. Thank you. How are we doing? Can I move forward? Okay? Raise your hand if you prefer I didn't move forward. Actually, I might not be easy. Okay. I'm going to let you 3 wrap up in about a minute, and then we'll move forward. Megan? Yeah. All right, let me get your attention again. Let me get your attention. Seems like making data is easy. Straightforward. So whatever you do in your research, just put those numbers in an array, put it in a data frame, now your data is in R. But it does happen that people don't use R to put their data frames. They get other SAS files, they get Excel files, they get files from people with data. Well, you got to know how to put that into R. The way to do that, first of all, you need Control-Shift-H. Control-Shift-H, wherever you save all the files, and you're gonna run into errors, people, I'm gonna tell you this right now. The error is not because you're doing things, you have to have every file that I asked you to save for today in one location, one folder. Okay, I said, what did I say, DVC_workshop, isn't that how you title it? You don't have to title it that per se, but it just needs to be in one location, all these files. Because this directory is saying, where am I pulling this information from? If you forget, say you're working in several directories, this code right here that says git work directory, git WD, that'll always tell you where you're working from. So if you're trying to load data and you're like, it's saying I can't load this data, it's broken. It's possible that your working directory is pulling from a completely different file that you thought were pulling from, but you end up weren't. But I'm gonna make this really easy for all of you. Some people, when I learned R, we had to learn all sorts of commands for pulling in files. Tables, web pages, SAV files, CVS files, there were all sorts of commands. And one of the reasons I had to load the Rio package is the Rio package just takes a simple function. It says import. It'll do the work for you. It'll say, oh, you have an SAV file. I know what to do. Oh, I have a CSV file, comma separated value file from Excel. I know what to do. So the Rio package makes loading data really easy. So I'm going to tell you right now, the Rio package is your friend for starting in R forever. Okay? What I'm going to need you to do, though, is I'm going to need you to pick Control-Enter and import all these data frames right now, because we're going to be working with these data. So every single one of those. And what will happen is they'll show up in this section. The body fat data, Metallica, my data, social network data. You don't have the Swiss data yet, don't stress, you're going to get there. So whenever you import data, that's where you're working from.
Where are these files?
The files that I sent, the registration. Oh yeah, sorry. Let me again one more time just emphasize Control Enter. You have to Control Enter these. And then they'll pop up. Okay.
Why can't you just hit one? Why can't you just oh.
I just I didn't do that because okay. Now. Oh, so sorry.
Like a technical.
Oh, sure.
So I was fine inputting it this way, but then when I tried to.
Oh no, you just need to set. You're setting the button.
And I try and just open it this way.
No, that's gonna open the. Yeah, that's only it's gonna open R file. R file.
Because when I open this, it goes into another something that I have with it. Oh, so I have to like import this way
Excellent. So I actually had a great question right here up front. These files, if you tried Control-Oing them and opening the SAV file, they're going to open them up in different programs. They're not going to open them in R and put them in your workspace. That's one of the reasons why we set the working directory to tell R, I need you to pull these files that aren't meant for R into R. But the next thing I want you to pay attention to is, look at this social network data. you actually get a tiny summary about it. There are 201 observations, 5 variables. If you double click that, you actually can see the data in your text editor. So again, you double click social network data, you're gonna see IDs, gender, age, Facebook times, and this data is actually done, it was done many years, it's outdated data, okay? Don't use this data for research. I think they're using MySpace and other things that just people don't use anymore. Yeah, don't worry. The whole point is they wanted to find out how often you use social network and what sites you use. But then again, what if you want to practice? What if you're like, I want to learn R better. I need data. I can't just invent my data all the time. What if I'm inventing data that's not helpful? R actually has built-in data sets, so you can Google what built-in data sets are. I just want to show you, though, how to import those built-in data sets. It's called data, and whatever you Google, for whatever reason you want to practice, like I want to practice on the Swiss data set, okay? Google said this is a good one to practice, and it told me it's a good one to practice. Well, this is all you have to do, data and the built-in data set. This feature is extremely useful. Sometimes you only need certain portions of the data, or you only need to look at certain portions of the data. If I only want to look at the first 3 rows and the first 4 columns, I would use these brackets after the data frame that I had saved or pulled from, and then it would only display the first 3 rows and the first 4 columns. So sometimes that's very useful to subset your data, or at least look at it as a subset. You could save this. If I wanted to save this, I would have to create a brand new array. Other good data sets are from the GPIC book. 2 data sets in particular I'm having you work with today are height, weight, and US population change. So do me a favor right now, and again, I need you to Control Enter and run all these lines of code. Okay? You do that. I need you to import this data. I need you to import height, weight data, and the US population change. And you're going to notice something right away. Look where the height, weight data ended up. This is where all your data goes. And yet height, weight is down here in values, and it says promise. I promise to give you your data. That's not freaking helpful. I don't want a promise. I need my height, weight data in my data frame. Okay? You also notice US population change. They made you the same promise. Here it is. Okay? So how do you fix that? This is an easy solution in my opinion. It's view with a capital V. So after you load a data set and it ever goes to the promise, just hit view. 2 things are going to happen. 1, it's going to unpromise. You're going to get your data. Hoo-ah. And 2, it actually is going to show you what the data is. So it did 2 things for you all at once. Sorry about that. I don't know why they make false promises. I don't know why R does that. I don't get it. I've never understood it. I think it's a tease.
It has to do with how it runs the environments. It's advanced stuff that we don't care about.
I hate them. Okay? That's how we feel about that. But I want to make sure you don't get frustrated when practicing. Okay? All right. Last but not least, you have data. Okay, you collect this data for a reason. Summary of whatever data you want. I used my data. You could have my data.to, whatever, doesn't matter. The nice part about summary is it does all these statistics for you. You don't do any statistics, you don't do any calculations whatsoever. Boom. I know what the mean is, I know what the max is, oh snap. I've got information at my fingertips. So we like this feature a lot. This function summary, extremely useful. Last but not least, we're going to go in this direction before we actually start applying this. Guys, I'm giving you a whole bunch of introduction stuff. Obviously, if you want to learn more about R, you gotta have a direction of how to get stronger with R. Yeah, I can't do that for you today. I gotta do the visuals. But the who, what, where, when, and why, simple function. And I'm gonna show you an example of when you'd want to do this. The psych package has a function called describe. It actually does what summary does. It gives you a mean, gives you a median, it gives you information, it summarizes statistics. It actually goes a little beyond, it gives you a standard deviation. When I did the summary function, there was no standard deviation, it didn't give me that. Oh, awesome, I know what the standard deviation of my input was, I know what the standard deviation output is. And then it also gave me this, math. What the hell is math? Oh, your math is 5.19. Do you know what that means? Your math is 5.19. What did you do? I thought this was cool. Now I feel stupid. I'm gonna go there. I don't want to show my professor. I'll be like, math is something unique. That's interesting. I don't want to be that guy. So how do you fix this? Question mark. That's how easy R is. Question mark and whatever function you use that gave you some funky mess. The describe function gave me some funky mess. I didn't know what it is. So how about I just question mark describe? And then what will happen is, in this bottom corner, right here, let's see, perfect. Here's the describe function. Here's the description of it. Here's how it's used. This is all the coder mumbo jumbo. But if you start scrolling down, you're actually going to find the definitions of every one of those outputs. You should find where Matt is. And now you'd be able to say, you know what? I don't have to do it. I can say, like, oh, it's the median absolute deviation. If you still don't know what that means, okay, you're lost. You got to go to statistics classes. Okay, now you need a teacher. But at least you didn't sit there and say, I didn't know what that meant at all. Or you didn't draw a sound. You didn't make a math. You know what I mean? You guys want to be able to use statistics with your advantage. You want to always seem smart. You always want to be this guy right here. Okay? I like it. He's sharp. But there are times when data sets, somebody recommends a data set, they're like, use the Swiss data set. I told you that. You know anything about the Swiss data set? No. Well, what if I question mark Swiss, and then next thing you know, if I do that, if I say, oh, question mark Swiss, then it'll actually give you a description of that data set that you're practicing with. Oh, it's the Swiss fertility and social economic indicators in 1888 data. Old school. Okay, but again, it's practice data. We knew that. Now it's time to visualize. Now we've gotten to the whole point of today's workshop. I've given you the ins and outs, the basics of R. Okay? If you have more questions, comments, and concerns, we'll more than willingly address those at the end. But for now, let's teach you how to take something like this, summary data, and make it look like this. Let's teach you how to make a story with your summary data, or whatever data you're working with. Let's show a picture about that and explain some aspects of that picture to people so that now your research looks good. Now you're entering research competitions and you're going to win. Strong purpose behind you saying, my plots are better than their plots. Now we're going to start with the toughest one. And all of them, the toughest one's going to be bar plots. And the reason why bar plots are going to be the toughest, for example, go to the social network data again. Okay. Here's why bar plots are the most challenging right up front. In statistics, they're technically the most easiest to work with. Categorical data is nice. You just have a category, you tell me how many people are in that category, bada boom, bada bing, bada bang. Well, look at your data. Let's look at this site. There's a category none, there's a category Facebook, there's a category MySpace, there's a category other. You know how many, there's there numbers telling you how many people were in Facebook? Are there numbers telling you how many people chose other? You can't make bar plots if you don't have some frequency that goes with them. And data sets typically are like, when you have a category male, female, if I had you at the beginning of class say, are you male or female? There's no tally. I don't have a frequency. I just have a bunch of M's and F's. So the code that I'm giving you right now is going to help you deal with that problem so that you can make bar plots. First of all, you have to tell what data set you're working with in R. Okay. Second of all, you have to tell it what column or variable you're working with in R. That is what the $ symbol is for. The $ symbol is saying, I have a data set. Specifically, I would like to look at the column site. If you wanted to look at any of the other columns, well then tell what column you wanted to look at. But the $ is going to do that for you. The table function is going to take all those categorical values, Facebook none, and it's actually going to count them up for you. Now, if you don't save this as an array, though, notice I got my assignment operator saying you got to save it as something. This function itself will just tell you the counts. It won't save the accounts. And that's why I wanted to teach you about arrays in the very beginning. There are times you need to save information to move forward. And I need to know this. I need this saved somewhere. I need to know that only 3 people back then went to Twitter. Only 2 people went to MySpace. Do we see how this is outdated data? Do we believe this right now? This is a lie. Okay. Facebook, I'm even hearing that Facebook's, is it me or am I hearing that the trend's right? It's on the down front, people are not using Facebook as much? I don't know this, I just started this conversation the other day. But here's what's nice. Once you actually have a frequency and a category, like I just showed you how to do, there you go. R will do things very nice for you. It'll say, here's bar plot. And then I saved it as frequency.site. That's how I saved my array. And just like that, I made a bar plot. You don't have to do anything. It literally is, there's Facebook, there's LinkedIn, there's MySpace. Now I could have showed them that table of the frequencies. It's not like that would have made sense, but for that reason, this is where visuals have power. People can relate. I specifically see Facebook and LinkedIn. Does that have an emphasis on how different they are because of how that visual of them being right next to each other? That's power. And I will never tell you to manipulate your data, never. But there are smart ways to visualize your data to where you're telling the absolute truth, but you get to make somebody see what you're seeing and have them believe what you're being so that you can push forward with things. That's smart. That's not lying. But in general, this is kind of plain. I think we can make this look nicer. Okay. What can we do? Well, one thing people tend to do with bar plots, a possible idea, this is called the Pareto chart. It's a bar plot that goes in descending order from which categories are most popular. So it kind of lets people see, Facebook, then MySpace. Okay, it kind of has this flow to it. Well, if I want to do that, you know, you're going to have to, again, this is where I'm telling you, bar plots are a little more complex than all the other plots I'm going to show you today. Is you're going to have to tell R to do that. So you're going to need to code. And luckily for you, we're going to give you this code. We don't want you to have to sit here and stress about code. I want you to be able to reference this in the future. And the only thing you're going to need to pay attention to is this. Frequency.site was not in this order. It just counted everything I wanted. But if you use these brackets after that array, tell it to order, and you're telling it to order itself. That's okay to have this. Some people think that's weird, but you're saying order yourself, please, and make the decreasing true. This is your way of coding that order sequentially. And again, I have to save it as a new array. So if I don't save it as a new array, R will give you the answer you want, but you can't pull it later on when you want to use it. So you're always saving these types of information. And again, bar plot is an easy function. Bar plot, tell it what you want to bar plot, and there you go. Question back.
Can you say that's the same piece of data?
If you want to erase it, absolutely. So his question is, what if I would have saved it frequency.site over here? Your original version got overridden by the new version. So it's just like saving a video game. Same player, new spot, new data, new information, new whatever. So that's up to you. That's coding preference. I've always been I don't know, I think of the scenarios. Sometimes I do it, sometimes I don't. I'm still thinking about my thinking. I don't, it still seems like we could do better. That's why you're here. All right, sweet, you show me a Pareto chart. I've seen these before. I want to stand out. This is where this workshop's really going to kick into place. So let's throw that away, okay? You can get creative. Sometimes making things horizontal instantly makes you stick out. It's different. Most people don't instinctively look at bar plots this way. And now it's like, oh, wait, what'd you do? Ah, you got my attention. That's one trick. Here's the function. Cores equals true. I'll just turn your bar plot on its side. Plain and simple. Now, coding aspects. So those of you who code and have coded before, I'll let you know right now. This new line after the comma is not necessary to code this. When I'm doing visuals, I code a new visual aesthetic line by line so that I can always see what I'm doing and what I'm changing. Because there are times you'll have a really complex plot and it's just line of code and then it's wrapping around and live and you can't see what changed or where the change is or how. It's not, for me, I don't work that way. So with my workshop today, this is how I code, this is how the code you're gonna get. You don't like it, you change it. But I'm gonna tell you right now, this is why you're seeing it the way you see it. It's my preference, okay? But it's still plain. I mean, it may have stood out a little bit. It was different. Let's find a way to make Facebook pop, okay? So in order to do that, I'm gonna teach you, this is a visual trick, okay? You're gonna dig this. I'm not gonna be taught this in your class. They're called color vectors. Color vectors are specific vectors of color sequences that you want. I'm creating an array called Facebook blue. So I'm going to use the color blue. The repeat function is super useful in this because I don't want to type the word gray 5 times, 10 times, 12 times, however times I have to type it. I like it to repeat gray 5 times. So that actually when I implement my array, so Facebook blue is actually just a bunch of words. Hence why I'm teaching you words are important in the very beginning of the arrays. Blue, gray, 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 gray. I've set a color vector. And now I can go back to the same plot, say color equals Facebook blue. And what have I done? I made you look at Facebook. Whether you wanted to or not, you probably would have instinctively just because it was the biggest one, but I made you look at Facebook blue because it definitely sticks out. But for good plotting ethics, you're going to want more than what I've just given you so far. Even though I'm teaching you this pops and this, I'm going to take off the horizontal. Notice I just didn't erase my code. Another reason why I line things down by down, because if I want to go back to horizontal, I know exactly where I am in my code and how to change it back and forth. Okay? But what I'm going to do is I'm going to take away the borders. I don't want this plot to have borders anymore. So now I've given you a feature that'll take away borders if you feel that's necessary. Access kind of stopped short. I don't like that. I'm now forcing the y-axis, the limits of the y-axis, to be between 0 and 100. That's how easy that is. Titles. Good habit. From the very beginning, from today, from now on forward, you make a plot, you title it before you print it. Always. You're going to get stupid titles with R. You're going to get titles that people don't understand. You just start with titles, and the way to do that is the main function. Main equals, call it what you want to call it. Labels. Label your axes as well. The xlab function will tell you the number of users. That's what I want you to know. So when you look at this plot, you'll know what that means. And this is one nifty trick that I was not taught until many, many good times with R. Sometimes you have really long titles. Appropriate to have a really long title. Well, R will actually just make one long title and cut off the ends. Yeah, oh God. And then you try shortening it, and then it sounds stupid, and now you're mad. This \n in the middle of your sentence will break it into another line. So this will be one line in the main title, and this will be a second line in the main title. That is a useful tool. And now this looks a lot better. What do you like better? We started. Now we ended. Just titles alone make it look professional. So do you see how little things can make a visual so much more better? It makes you look, don't get me wrong, both of these have the same exact information. But if you're going to submit something, is it clear which one you'd rather submit? I didn't do much other than I took away the borders. I made sure it went from 0 to 100. I gave it some types. Do you have any questions for me? Sure.
For example, if the Facebook color is blue because you assign it as a vector of blue. So in any case, when Facebook is not the highest number of in frequency, then the Facebook category will not be blue anymore.
That's right. So what happened is, because I set my color vector, I started with blue and then went down to grays, but I knew my frequency vector had the highest and went to lowest. So in that color vector, if I wanted this to be blue, it would have had to have been that third value that was blue, because that's how I set up my numeric values. So your color vectors have to match what you're talking about in regards to what you're naming your plots. Okay, the frequency, the color vector.
For example, LinkedIn, we want LinkedIn to be red. So regardless of the whatever order it is, can I make it happen?
I would stick with actually keeping it's either keep them all one color, because that's a very easy thing to do, but if you're trying to make specifics, you should set your color vectors to specifics. Yeah. But he was, if I want all these blue, that's actually very easy. You don't need a color vector for that. That's just telling, change the whole dynamic of the plot. Okay, and I'm gonna go a little more into that as we continue. Box plots. Some people love box plots, some people hate box plots. I'm gonna let you know when it comes to summary statistics, that summary I had you guys do, just to do all that statistics math for you, this is the best plot to match that. So if you're trying to visualize summary statistics, here's your bet. So again, that's important. What did we use bar plots for? Categorical names. Male, female, old, young, political party, whatever, doesn't matter. Category, that's what a bar plot's for. Don't try using a histogram for categorical data. Box plots are summary data. Now, check this out. We have the body fat data that I had you install. Look at that awful, awful plot. Does that help you with anything? I don't really understand anything about it. I mean, if you do know the aesthetics of what a box plot is, excuse me, you know there's a median somewhere, you know there's a quartile, you know there's a, but in general, is this helping me? Do you know anything about body fat with this? Here's one of the things that I'm trying to teach you in regards to visuals too. It's R's only going to do what you tell it to do. And if it has no other information, it thinks it did it perfectly. And so I'm going to teach you how to fix this. Sometimes you're going to plot things like I'm plotting X1. That's not even helpful either. What is X1? So let's go through this. Again, you have the body fat data. You double click that. X1 happens to be the tricep skin fold thickness. So let's zoom this in. The trifold thickness. Okay? That's helpful. I can use that information for my plot to at least help me learn more about it. So exploring your data is always crucial too. You just don't want to box plot things right up front. You got to know what you're working with. And so one of the things that I'm going to just do to clean this up, and again, why I'm mentioning this is good habit, is just put labels. Just putting labels instantly tells you more about this visual. Oh, that's the box plot. That's the summary data for tricep skin fold thickness from the body fat data. And again, at that point, if you're sharing this to people, people will at least be able to reference your title because they know what you're working on. So well played, people. If you can do this every time, make a plot with the title, you are already leagues ahead of regular people who don't do anything with visuals. Okay. That horizontal trick. Look how it comes into play again. It's the same information. Does it look different? Slightly. Does it have new meaning to you? Possibly. Your eyes see things. This is art now. And at this point, when you're doing things with art, you have to work with what works well for you. Horizontal equals true. We'll do this. But it's still blank. Oh, nicer. Much nicer. I like that better. I don't know why. That has a different tinge to it. What did I just do right now? I took the same piece of information and I just made it look completely different. Which one do you like better? At this point, it's preference. Do you like the blue one or not? It's too thin for you. Okay, fine. These are the choices that you get to make. But clearly, you can see differences, can't you? What's the difference between this original version and this new version? Go on, yell them out. Differences you clearly see. Color. Thickness. Thickness and shape. Okay, yeah, there's more. There's no staples? Those are the end bars? Yeah, there's no staples. This one's just stapleless. What else? Dotted versus line, right? Little tweaks. Little tweaks. But again, I want you to have these code with, I want you to use this. Here's all the code necessary to do that. Okay, and it has their own purpose. First of all, I reduced the thickness to 25% of the original size. If I wanted it 50%, I would have put 0.5. If I wanted it 2 times as thick, I would have put 2. It's using a ratio scale. I added some notches. Those notches are confidence intervals. Okay, we can talk more about that later in your statistics class. These are the whiskers, and I set it to equal to 1. That's how you get solid lines. And again, that's coded for you in your notes. It tells you. And again, the staple, I put 0 because I took the staple off. Now let's go back into colors. So I know you had a, what was your name, sir? I'm sorry. Anne? Yeah. Anne asked about colors. First of all, I want to reference you to this cheat sheet that we've given you. This cheat sheet will talk about all types of color schemes and packages that use specific types of sequential color schemes, qualitative coloring schemes, color schemes that kind of have extreme one end, like whitishes in the middle, and then extremes on the other end, which are useful in just different types of aesthetics. It also will tell you, here are all the colors in R that you can use. You want to use Medium purple 3, you can. I'm not stopping you. All right? That's all of you. You want to use gray 81. You're right here. Why are there 2 sets of grays? There's the English version and the British version. One spelled with an A, one spelled with an E. Big difference. Okay. So this color cheat sheet is for you and making sure that if you want to use colors, like royal blue, I'm going to use royal blue. I knew exactly where I could pull from and how to do that. Now this is your time to visualize your. In the plot where it says my.data, you can now put your data, my.data too. You want to change your visual. Your visual is not going to be the same as mine. But what I want you to notice is that I didn't use a $sign, which specifically means I'm not telling it to plot one specific variable. In my.data, I had an input and I had an output. And because I said use my.data, it's going to use every part of my.data. I like to make labels horizontal sometimes. So there's a function to do that. And now you have that at your fingertips. I'm going to keep the box with 25% of the original. I'm going to take off the notches. I'm going to use the color royal blue. So again, we got color royal blue. Now that's going to change every aspect of it. I didn't set a color vector. I said use royal blue as a dominant color. Outliers. One of the things that box plots do very well, is it does outliers. Shows you data that doesn't belong in your data set per se. And there are statistical references to that. This function right here actually lets you change the shape of those outliers. I'm going to give you another cheat sheet later on in the workshop that says the number 2 makes a triangle, the number 4 makes an X, the number 16 is a filled circle that's black. And there's more numbers, more different shapes, things like that. We'll get to that. But I want those outliers to be different from everything else specifically. I also want to change the color of those outliers. I want them to be red. So now I've made it really easy to see. These data values didn't really belong in my output. They seem weird. These data values didn't belong in my input. They seem weird. And now you're able to use this information for your research. You came up with these data sets. You needed a summary of them, and now you showed somebody how useful that information was. We need to pay attention to this. This is a problem. Does this happen normally? Is this an unnormal thing? I don't know the conversation. The whole idea is that you use box plots not only to find outliers, but to compare data. Do you see how there's a difference between my outputs and my inputs? And that's very easy to see because I had them plot both of them together. So make your plots useful. That's what you want to do. Questions?
How would you?
How would I make this a completely different? Oh, how would I make each one of them completely
How
different?
do you assign colors to different? And that kind of goes back to the other bar graph that we have. How do you make like each column a different color?
You can set, again, with the color vectors. And I haven't done this off top because I actually don't use, because I'm going to teach you, sorry, I don't want to get the Instagram set. There's actually another function to do box plots. I just want to teach you all these base values. But in general, I would set a color vector. Just these vectors where you're all like, my.color. And then you're all like, I wanted everything, like in the bar plot, for example. You wanted things to be different. I'd be like, first let's start with red, and then let's start with blue, and then let's start with green, or go with green. Like you can set each one of those values.
Okay.
And so I would imagine that's kind of the similar situation. But again, since I haven't coded that specifically recently, I'll have to do it right after the workshop to answer your question.
Okay.
But there is a way. The answer is true. You can make the way. Now, histograms. Changing gear now. People get confused between histograms and bar plots all the time. Is there anybody in here who thinks they can give, let's think about it for a second. Actually, talk to your neighbors. Talk to your neighbor right now. What do you think the difference between a bar plot and a histogram is? Ask your neighbor right now. Good conversation, right? Good conversation. And I actually heard a lot of different answers. So let's come together. Histogram and bar plots, they look extremely similar. Hence why people get confused all the time. This is common. Okay? The difference between histograms and bar plots is very subtle. It's what you're doing is you're taking, they call it quantitative data, so numbers. And what you're doing is you're putting them, you're categorizing numbers. So the numbers between 60 and 70 are now a category called a bin. Or specifically, R likes to call them a break. And it's basically saying, I have so many numbers, I don't want to look at each one individually. I want to group them as a category. Whereas bar plots themselves are just plain categories. No numbers. We talked about Facebook, we were talking about MySpace, there was no numbers involved with that. We're just talking about categories. So that is the distinction between them. We're turning values into categories. Now, as I said, histograms have what are called bins or breaks. There was one break, there's another break. I wanted to go through this. There we go, there's 7 more different breaks. Okay. So let's learn something fun. How about we break our breaks? How about we get a little constructive work going on? Okay. I just plotted the histogram, social network data from the age category. So now I have all these ages. I categorize them from 0 and 10-year-olds up to 60 to 70-year-olds. Okay. I wanna break these breaks even more. Perfect. I dig it. What did I do? I did exactly what I said. I put more breaks. I broke my breaks. This has a better feel to it for whatever reason. I like this better than this one. This is, to me, over-summarized. And that's one of the problems with histograms. Up front, I'm going to teach you right now. Histograms is an art. For you to say, I want R to do all the work for me in histograms, it's not going to be the case. Because clearly this is the same amount of information, and yet I got 2 different stories from this almost. Okay? Maybe you do need this one. I don't know. Maybe you need, again, it'll come down to you making those decisions, but you have to be familiar with this when you're working with histograms. That if you don't make these decisions, someone's going to make a generalized one for you, and it might not be that good. The next thing I gotta kind of warn you about, and I'm super sorry about this, I've had troubles with this in the past. Clearly, I told it to do 10 breaks. R did 13. Like that better. Play around with it. You know, there are other programs, as I said, I've been doing this for a while. I started using different functions, but this is how we get familiarized with R. But I do know for a fact 13 isn't bad. It may not have been the 10 I wanted, but okay, I'm gonna work with the 13 and go from there. What's important now is that when you have a histogram, you really need to learn how to turn frequencies into probabilities, okay? This is super important, okay? On the side of the y-axis, it was just telling you how many bins were in these bins. But if you need, and you're going to need, probabilities to describe, 30% was in this thing, 60, you're gonna need that. This is the function or the command that says how to do so. You know what? I have my social network data. I really just want the probability to be true. Okay, now I'm not worried about frequency. Obviously, I have this breaks function in here. I have an X limit and a Y limit. I chose these. These were my specifics. No, I didn't want the Y limit to go very high. I wanted the X limit to go up to 80. You work with this data. You start making these types of decisions. What sections of your axes are important to visualize? But again, let's bring this color vector up. And I definitely I knew this was coming up too, so I was going to show you this later. I want light gray 2 times, I want green, and then I want light gray 10 more times. So I don't have to type these out again, I use the repeat function. That's going to set a color vector where the third term is green. Does that make sense? Okay. Now, did I specifically choose the third term? I did, and you'll see why. But again, I knew that going before I set this color vector what I wanted. I'm going to give you this added tidbit. I felt like in the entire presentation, this was the best place to put it. I know I have no other place to put it because I think this is cool as hell. There is a way to put a subscript in your labels, like a subscript. I don't know why I like this, I do. It's these 2 commands right here. Sub, whatever you want it to say, and how big you want that subscript to be. So let me give you a visual of what's going on. I made the tallest bin stick out. I needed you to look there. I also wanted to show you that's super cool if needed. You could put a little annotation. And believe me, I've actually used this a couple times in my life, and it's been very useful to have just this little, like, 4-word sentence, 3-word sentence, 10-word sentence, whatever you need, I don't know. But this is the only part in the presentation I can think of putting it, and it has no real relevance to this picture, but now you know. Now you know. So why is it tremendously important to have this probability aspect? The probability aspect lets you put in curves. And I heard people actually talking about the difference between bar plots and histograms. They're saying, well, there's this density. I heard this word density being used. Densities have a lot of statistical power. And whether you're familiar with those types of statistics or not, at least you have the code today and the way to actually implement this for future reference. You can only add a density curve to a histogram if this probability is true. Okay, so if you have that frequency, R's gonna get mad at you. It's gonna say don't do it. You're also gonna need to assign a mean and standard deviation of the data. So right here is 2 extra lines of code. And what I did is I said, you know what? The social network data for the column age, I need to create a mean. This is going to be a household code too. NA.RM equals true. R will get mad at you if your data is incomplete. And in the social network data, you can look through it later, there's missing ages. That's gonna happen a lot. You're gonna work with people in your group and they're gonna give you data that's incomplete. Ugh. Keep this in mind. NA.RM equals true is your way of saying, you're telling R, please don't get mad at me. Okay, you're okay. You also need to do that for the standard deviation as well. And then what you're going to do is you're going to form this line. D-norm is R's way. This is one of the benefits of R. It's a statistical program. It's meant to do densities and advanced statistics. So this D-norm is how it's going to create what this line should look like, this curve should look like. It's going to be based on some mean, which you set, and some age, which you set. Question, I had a hand raised.
Yeah, could you go back over the NA/RM? Is that just saying like NA, answers of NA, like not applicable?
Basically, yeah, empty spots, NAs. Sometimes people do put NAs in the data.
Okay, yeah, I'm just saying like .rn, because that's the command for removing something.
Yes.
Is that saying just ignore?
Ignore blanks.
But it's not removing it from the
No,
data.
not at all. Not at
It
all.
removes one in the function that calculates them. pass the entire data set in, first thing that it does is if that's true, it gets rid of the blanks and then reduces it.
Okay,
But it's not going to take it out of your data frame.
okay.
Yes. And then I tend to have thicker curve lines, by the way, so this is the function to make lines thicker. And you have to put this add equals true feature. Because if you try running this by itself, it's not going to work. So I've done this. It's actually, this is the slide title. Run code together. I don't know how they would go about this. Here's everything I just showed you. And notice how these two lines of code are right next to each other. You can put control enter to work. You can highlight everything, control enter, however you want to go about it. You need to run both these at the same exact time. Otherwise, you won't be able to add this curve. So if you try doing it with just that top piece, again, you're going to get what we had to begin with. But if you want to add the curve, you're going to have both lines at the same time. And now, this is important. Maybe for your research, you're like, I want to show you how my data represents a normal curve, whether good or bad. You now have a really easy visual for that. It definitely, I don't know. I don't like this. It's supposed to be normally distributed. It's supposed to fit the curve. So again, that's more information. That's power to your visuals just by adding a line. Now, I get this confusion all the time. What's the difference between a density curve and a normal curve? I think what's confusing about this is people will say normal density, and people will just say density. And so they're using this same word density in stating both. A normal curve is a bell-shaped curve. A density by itself is a curve that fits your shape. There's a difference between those two. I also think it's important that you know how to do this. So let's go back to code. Nothing changing. Okay, it is important that you keep the probability equal true. But this time, don't forget to tell, because you don't have to sign means or medians anymore. You don't have to, means or standard deviations. You just have to tell the function itself down here. Remove any missing data. And so again, just go social network age, remove any missing data. I need another line that is a density, just different coding structure, but I want you to have this. So that way, you're good to go. And you can get this one. Different, same thing, different visual. Questions on this? Okay. This is now your time to play. I've got some more things to teach you, but now I've given you box plots, bar plots, and histograms. Let's play with your data. You have data frames. Start exploring it. Some are numeric, some are categorical. It's your turn to play for the next, let's call it the next 15 minutes. Let's make some plots. Pick some new variables. Create your own data. Please raise your hand if you would like any of these of the DVC workers and myself to come and assist you. I'm gonna turn on the lights. Jump on in. Show us your plots. Show us what you've learned.
I still haven't been able to reinstall that. I don't know what to do.
Well, I will help you because I feel like you're such an attentive learner. Okay? Because you uninstalled and reinstalled our.
Yeah.
Oh. That's what I was wondering, like, is it, I can't get in.
Yeah.
I was like, is that it?
Okay, so I would probably every time you go to a working group, yeah, I would say
So like, I don't know why, I don't know what to do it. Yeah, see, it does a different.
yeah. Very cool. Very
Yeah.
I was close to that.
Yes.
This one here has the bars.
Now we good to go?
I don't want to.
We're still trying.
I showed you a bunch of.
Yeah, we connected. I suggest restart our studio.
I'm stopping share for a split sec, Michelle, to pause the recording. All right, ladies and gentlemen, let me get your attention again. Let's come back to this questions comment. Now that you've had a chance to look around, the next thing I observed purposely was there was questions that came with, how do I do this? 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 Well, this is probably the best place to reference. This is where Data Visualization Club has its strengths. They are a reference club that teaches you how at least to find the resources to answer those questions. And they may not know the answers right off top of the spots, but they do know, you know what, this is a way I have dealt with that situation and point you in that direction. So Data Visualization Club meets on Fridays at 5 p.m. every other week or so. Next Friday, they're doing, their club meeting is going to be about our guru. Our guru is a free online platform. How would you call it? So what would we call it per se?
It's basically, it does everything that we did today,
Yeah.
except by pointing.
Yeah, it's basically doing everything we did today for free, but instead of coding it, you would click, 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 and then it does it for you. It's a more user-friendly, I would say it's a non-quarter way of doing what we do. If you are interested in coming to their meeting next week, there is something that they have asked me to ask you. You do need to let them know that you are interested in showing up next Friday at 5 p.m. It'll be in the room next door. And the only reason they need to know that is because they need to know your email. They have to get you this free access. So all they need is your school email. But again, you'd show up, you wouldn't have access to our group because you didn't let them know that they had to register you into their access frame. Okay? So just FYI on that piece, if you are interested in learning more about our guru and how to do things at a click, click, click in a non-coding perspective, they will host their meeting, and Dr. Wayne is probably going to be taking charge of that. He's definitely wrote code in the background that makes all that happen for you guys. So he's actually part of the creation team. Other than that, DVC also wanted to let me share with you that they're having social events next Friday. There's a bowling night right after that meeting. So going to the TSU bowling with a bunch of other of the the College of Math and Science. Pizza, drinks, good times. Just join they want people to know that they are a social group as much as a reference group at the same time. So if you have any questions, comments, and concerns about DVC, Miss Megan is the club secretary. She is definitely a go-to person. So ask away. I know a substantial amount about the club. Dr. Wayne does too. Rico, we're all team players. We're basically here for one reason: how to make data. Okay. And so I want you guys to know that that is available. It is a school club. It is free, no membership fees. All you have to do is have an interest of wanting to improve data visualization. Okay. Next and last, scatter plots. Sometimes we need to find relationships. Is there a relationship between this variable and this variable in our data? Well, a scatter plot is an easy way to do that. One of the things, here we go. Here's what you have to pay attention to. Actually called the plot function. I'm going to use the height weight data. Specifically, height in inches and age per year are the two variables I'm interested to see if they have some relation. This tilde function is saying your height in inches as a representation of your age per year. Another way to think about that is your first term is going to be your y-axis, your second term is going to be your x-axis. It's saying this. It's another way of looking at it, easier way. But you need that tilde in order to represent that, because R won't know. Okay, you can't just make things business. But gosh, it happens all the time. I see this all the time, and I want to make this a big point in today's workshop. How awful those labels are. Don't show this to anybody. Okay? It doesn't make you look impressive. Okay. We gotta clean that up. Okay, so think about bad habits. That is an emphasis on today's workshop. Don't do it. You do this particular way. Okay. Give it some labels. Here's what's nice about everything I've been teaching you up to this point. It's all the same mess. How do I give a main title? What do you think? How do I give it a label on the y-axis? Y lab. And x-axis, x lab. Easy stuff. And just by doing this alone, you tend to just have, that says it in me. This is height versus age in school children in 1967. There's their height in inches. There's their age. That's useful up front. Okay, now talk to me. What is it that you wanted me to see? I'm trying to show you that there's a relationship. Oh, okay, good. We started this conversation. I like it. That scatter plot's boring. Boring. I know. We can do more. We'll do more. We'll be better. So now let's start getting into the nits and grits of how to make things look aesthetically a little pleasing. The PCH function, specifically equaling 21, will give you circles with no color. You put BG right underneath it, and you say, I want these circles to actually have some color. Please go ahead and tell it the color. I'm sticking with royal blue. I was feeling it. I was feeling royal blue. I knew when I came to present, I was feeling royal blue. This whole day is about royal blue. I was loving it. These are the types of things that just add a little more. But how do you know how to change the size? Okay, you're not going to memorize these things. You're not going to sit there and say, oh, I remember PCH 16. I do this all the time and I forget it's PCH 16, okay? That's when you have this reference graphical parameter. In your R code, you should be able to scroll over this, hit the shift key, and then click the link, and you're going to be taken to a web page. This web page is your guiding structure from day one. Okay? The section in the web page I'm specifically going to look at, so if you scroll down, it's plotting symbols. So this web page has a lot of information on it, clearly. Plotting symbols now you're going to learn where these numbers come into play. Okay? 21, 22, 23, 24, 25. Those are the shapes with no fill. And then you put BG. BG will fill 21, 22, 23, 24, 25, the colors you want. All these other ones are defaults. Don't get me wrong. But it'll be a different command. I just wanted you specifically to see how to fill in the blanks, because I've known people to try and use these and they don't understand what's the difference between 1 and 2 and 3, like their same symbol. I'm expecting that. So, again, scroll down this. I'm not going to go through everything in the presentation. Scroll down. What else are you seeing? Are they teaching you how to make lines thicker? Are they teaching you how to make dashed lines? Are they teaching you this web page again? You're going to want to save. If you're interested in using R, you save this link. This is a good starting point for anything graphical. Now, you have the power to make your dots bigger and smaller. Sometimes you need to emphasize big dots. Sometimes big dots can be frustrating, and you want tiny dots. Well, the CX function, or the CX command, if I said, let's go back. Oh, man. If I said I wanted it to be 1/3 its original size, or roughly 1/3, 30% of its original size, I can make them, I can shrink them. So it's always based on a ratio perspective. I want it 1/10 the original size, a tiny, tiny little dot, then I'm going to put 0.01, okay? You can, again, opposite direction. Put 3, so the 3 times its original size, it might be overwhelming. I don't know, maybe that's the point of why you did it. Maybe it looks cool that way. I've never tried. This is something that it took me a while to learn how to do, and I'm giving it to you up front. Sometimes with labels, you want the label printout, like height in inches or age in years. Maybe you need that to be bigger. Maybe you need that. That's something that they need to read right up front. You need them to know. And it's just R's not giving it the right size you want. This is a way of scaling those types of things. Same for aspect, I want it 1.2 times its original size, and now all my labels are going to be bigger. CX.main is going to talk about the title. Sometimes titles are too big. I need my title smaller. There you go. I need it 10% small. Let's make it 0.9 its original size. This is a very useful scale. I like to do this. I like to change the color of my labels. So instead of messing with the size per se, I want my labels to be a completely different color from the regular text so that they can stand out in that regard. This is something I like. Well, then you do color.lab. Okay. Slate blue is the way to go. No longer royal blue, it's slate blue. Okay. There's that. I didn't need any fills per se. I just needed tiny little dots. I wanted them shrunken down. I clearly changed my labels. Now it's the same graph, but it has a different feel to it. So it brings us to a really cool feature. The last package I had you install is the car package. And the car package has a really sweet function. It has the scatter plot function. All this code right here, every single piece of this code is the same as the code you did before. Nothing new, nothing changed. Only difference is I loaded the car package, then I need to do the car. And instead of plots, how about you do scatter plot? Now you get this. Now this makes you look real cool. Now this helps shows I'm clearly seeing a relationship between my variables. It seems to be somewhat of a positive relationship. Coding-wise, I'm going to let you know, not all things come with legends. That's something you're going to want to practice, get better at. But if you code in a legend, boom, makes your graph even easier to read because you're telling people what means what. So that red line is what's called the LOS. It's a line that fits your data per se, kind of like that density line that was fitting your data. And then you have the mean fit, which is your regression line, which said, you know, this is the smallest error that fits all the data. What are those dotted lines around it? Those are confidence intervals. Again, if you're unfamiliar with that terminology, again, in your statistics class, you ask, can I learn more about confidence intervals? It's saying we expect 95% of our data to fall within this helium. This is a powerful conversation. What other cool things do you see about this? What about the outside? Did it give you some box plots too? It gave you some simple box plots, so now, even though you're comparing data, you also can look at individual data. That's powerful. That's a plot that'll help you stand out above any of your classmates. Ladies and gentlemen, that is the end of today's workshop. I hope you've enjoyed our presentation. What I need you to do right now is I need you to hit shift and click, and there's a short 1-minute survey, maybe 2 minutes if you're feeling ambitious, you need to fill out for us. And there are refreshments outside for you to enjoy. And questions and comments, concerns, please raise your hands. You have a leaderly group willing to help you. It has been my pleasure. And again, my name is Randall. If you have anything you ever need in life, come visit, okay? All right then, thank you so much. Yes, Miss Holler.
Randy, would you like to stop recording?
I sure do.